11.4, distance formula. So we've got a picture, and it says find the distance, okay, of all three sides of the triangle, and it says to simplify our answer. So distances, meaning we've got to find the lengths. We've got this triangle here, so I'm going to find the height of that triangle. Well, because it's on a grid, we can count the boxes. Really don't have any calculation to do there. Okay, it's a nice vertical line. We could count that it's 1, 2, 3, 4, 5, 6. So I know that side AC equals 6. Okay, I put a little bar over AC because that indicates that we're talking about that side of the triangle. Yes. Now I'm going to find side BC. That's a nice horizontal line, so I can do the same thing to find the length of BC. So go ahead, count that up. And we know that it's 1, 2, 3. I'm left with trying to find the length of AB. Now, AB is a diagonal line. I can't count the boxes. But we know that it's a right triangle. We have something to use to find the sides of a right triangle that we've been using all along. We're going to use Pythagorean theorem because we already have some information. We have two sides. We've got to find the hypotenuse. So all I'm going to do is substitute, just like we've been doing. Leg squared plus leg squared equals hypotenuse squared. 9 plus 36 equals c squared. 9 plus 36 is 45 equals c squared. Take the square root. Now it says simplify the answer. It doesn't tell us to the nearest tenth or nearest hundredth, so we're going to have to remember how to simplify a square root. So I'm going to think of my factors of 45. So 1 and 45, 3 and 15, 5 and 9, and that's going to be my winner because 9 is a perfect square. So square root of 9 times the square root of 5 is c. And I know that square root of 9 is perfect. That's a 3. If I cross it out, I know that my hypotenuse in simplest form is 3 square roots of 5. That's the length of that side. That's how long it is. So two of the sides we could get just by counting. Okay, 6 and 3, and then the hypotenuse we had to use Pythagorean theorem. Question number 2. Points P and Q are plotted on our coordinate plane. So P is 1, 2, and Q is 6, 3. Find the distance between those 2 points. So they want us to find that distance, and I probably should draw that in a little bit straighter than I just did. Okay, so from P to Q, that's the distance I've got to find. Can I count that distance? I can't because it's diagonal. I need a perfectly vertical or a perfectly horizontal line in order to count. So I can't count it. But what I can do is I can make my own little right triangle out of it. Because we know how to use the Pythagorean theorem to help us find the lengths of the sides of a right triangle. So right now, I know that this little side right here is 1 box. And I know that the base of this is 1, 2, 3, 4, 5. That's 5. So I've got both legs. I need to find the hypotenuse. And that's what the question is asking us to do. It's asking us to find the distance between P and Q. Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. 1 plus 25 equals c squared. 26 equals c squared. Take the square root. square root of 26 is the distance between points P and point Q. 26, square root of 26 cannot be simplified. There's no perfect square factors in it. So the length of that is in it. Oh, it says the nearest tenth. I lied. So let's go to our calculators. Square root of 26. So we've got, what do we get? So to the nearest tenth is going to be 5.1. Okay. Now, we have a formula, a new formula, that can help us calculate distance without having to make a triangle, without having to use Pythagorean theorem. We have another formula. And it looks like this. Distance equals. This is going to kind of look familiar to you. Parts of it are going to look familiar. Okay? y2 minus y1 squared plus x2 minus x1 squared. Where have we seen y2 minus y1 and x2 minus x1? Slope formula. Okay, we've seen those in the slope formula. So now we've played with it a little bit and we've made something called the distance formula. The distance formula is going to help us find the distance between 2 points. So let's go ahead and use that in example 3. It says find the lengths of all 3 sides of the triangle. We're going to simplify the radical if we need to. So when I look at this triangle, I don't have any vertical or horizontal lines that I can count. So that leads me to the distance formula. I have to use the distance formula. I don't have a choice. So let's start out finding the distance from point A to point B. And to keep things nice and neat and organized, D stands for distance of AB. Distance from A to B. So A, I'm just going to write this a little bit larger, is 4,1, and B is 0,3. So if I'm going to find that distance, A is 4,1, B is 0,3. I'm going to list all my points out up here. 3, -4 is C. Now we're just going to substitute. So if we're going from A to B, x1, y1, x2, y2. I've got that formula up here that I'm going to just plug things into. So I've got the square root y2 minus y1 squared plus x2 minus x1 squared. Now it's going to be a big calculator problem. A big calculator problem. So you are going to enter just what you see underneath the square root. Don't type in the square root. Just what I've just highlighted. So don't use the square root key. Type in with the parentheses, with the square, everything that I've written, and get a number. So I'm going to do a little mental math in my head, but you guys are typing this into your calculator. Okay, I got a number. You got a number? Who's got it? Anybody shout it out.
20.
20. So it says simplify, so I've got to simplify 20 into 4 and 5. I know that's a 2. 2 square roots of 5 is my distance from A to B. Okay? I've got to keep going around my triangle, so now I'm going to find the distance from B to C. So that distance right there, B to C. So B to C. I go to substitute. I look at my formula. -4 minus 3 squared plus, let's see, that was y2 minus y1. Now I've got to do x2 minus x1. And this is where I go to my calculator for just what's underneath the radical. So you're going to type in exactly what you see underneath the radical. So, yeah, okay, I got a number in my head. What's the number?
Hold up. I got some
7.
I don't think so.
I just
I got 58.
58.
58.
Okay. Everybody just all of a sudden kind of jumped on that. Oh, yeah, I got 58. Yeah, okay. So, the distance from B to C, 58. I got to pause because I got to think about 58. So, the square root of 58 does not have a perfect square in it. I had to pause the video because I had to think about that one. All right, so the length from B to C is the square root of 58. I'm going to stop the video and I'm going to have you guys come to class with the distance from A to C done. Okay, so that one is on your own. You're going to do the distance from A to C and come to class with it done.